Gravity, also known as gravitation, is the fundamental force of attraction among all matter and is the most important of all interactions in our universe. CPEP's chart explaining gravitation from Newton to Einstein is an incredible resource for those interested in understanding why objects fall to the ground on Earth, how planets stay in orbit, and in learning about the force that makes it possible for us to live on Earth. Without gravity, humans and all other objects would become weightless. The moon would collide with the Earth, and the Earth would collide with the sun, and the atmosphere would disappear into space. Basically, we would never be able to live without gravity. In 1687, Isaac Newton was the first scientist to establish the quantitative science of gravitation, which helped determine the relationship between free-falling objects on Earth and the force that keeps planets in orbit around the sun. In his theory, he postulated that the gravitational force between objects must depend on the mass of the objects, and that the force is proportional to the product of two masses divided by the square of the distance of separation. While Newton's law of gravitation was an excellent advancement in science and is still used to calculate trajectories, it lacked much understanding on how gravity actually works. It wasn't until the early 1900s and the discoveries of Albert Einstein when physicists began to understand gravitation much more deeply. In 1915, Albert Einstein published his general theory of relativity, which postulated that in the presence of larger objects, gravity is not actually a force, but instead is a property of space-time, and that space was indeed affected by the objects inside it. Einstein realized that massive objects had the ability to warp and cause distortions in space-time. Earth's mass is able to warp space-time so that time on Earth is dilated and takes slower than time in space. Today, his theory of general relativity still remains to be the best understanding of gravity and plays a crucial role in the understanding of gravitational waves. Gravitational waves can be defined as ripples or pulses in space-time caused by the previously mentioned disruptions by massive objects and the waves that carry great amounts of energy as they travel. The strongest gravitational waves are produced by high-energy events such as the colliding of black holes, the explosions of massive stars at the end of their lifetime, or other colliding stars. Einstein had predicted the existence of these waves, however, he believed that the proof of their existence would be impossible to detect. While it did take many decades to detect, LIGO was able to confirm their existence, and the waves were detected on September 14th in 2015. The waves were a result of the merging of two black holes, and the signal was believed to have been traveling for billions of years before reaching Earth, and the power radiated during the merger emitted the equivalent of 3 solar masses of energy. There's still much to be learned about gravitation and many new discoveries that will hopefully emerge, but this chart is an excellent guide into the fundamentals of gravity, black holes, and gravitational waves.